Okay, so now we're going to jump chapters because they put these together in a different chapter. Some schools don't treat or cover exponentials and logarithmic functions, but our competencies require we do. So I'm pulling in these two sections. It is new derivative rules. These are derivatives of exponential functions and logarithmic functions. Again, both of these are the types of functions that we reviewed in that lines and functions review packet before. So you should definitely remember what exponential functions are. So let's dive right into it. It says derivatives of exponential functions. The derivative of e to the x is e to the x. One of the very, very few functions that's true for. So remember what a derivative is. If you remember what e to the x looks like, so that's e to the x, something like that. What we're saying is the slope of the tangent line at every point is the same as the function value at that point. Very, very interesting and deep function. Remember this e to the x. E is a number. 2.71828 and goes on forever, right? E is a number here. It's a number that occurs naturally in the world, and the rate of change at any point in time is the same as the function value at any point in time. A really, really cool concept, a really unique function where the derivative of the function is the function. So the only other one that I can think of, quite honestly, how about 0, a constant. The derivative of 0 is 0, so the derivative of the horizontal line, y equals 0, is 0. That's not very interesting, though. Very few other functions can you say the derivative is the same as the original. And then if you look, what did they do right here? All they're doing is the derivative, they're just doing the chain rule. So if it's not just x, if it's something like 2x plus 1 in that numerator, you would still say it's e to the 2x plus 1. So you use e to the same thing, but then you have to remember to multiply times the derivative of whatever that exponent is. So multiply times the derivative of the inside. So let's jump to the example. Example 1 says find the slope of the tangent line. Again, that means find the derivative at a given point. They're giving us two separate points here. Our function is f of x equals 2e to the x. They're giving us the point 0, 2 and the point 1, 2e. Nice of them to at least give us the y values as well. So what we need to find here is we need to find the derivative of the function. Well, the derivative of e to the x is e to the x. So we're going to use the constant multiple rule on this one. What do you do with the 2? Well, it's 2 times something, so the 2 stays there. And again, the derivative of e to the x is e to the x. So this is simply 2e to the x. That would be our derivative function. Well, then we just need to evaluate it at the given x values. So again, this is somewhere where I'd probably use my table because I'm plugging in multiple numbers. It's not really hard to do, though. We're plugging in the number 0, and we're plugging in the number 1. So 2e to the 0 is what we would have, or 2e to the 1. I don't know if you need your table feature or not on this one. E to the 0, anything raised to the 0 power is a 1. 1 times 2 is 2. E to the 1 is just e, so again we would have 2e. So again, this is what I was explaining earlier, that e to the x is one of the really, really cool and unique functions, that the slope at the point is the same as the y value at that point. So we just found that the slope of 2e to the x at the point 0, 2 is 2. And the slope at the point 1, 2e is 2e. So the slope at that point is the y value at that point. Really, really cool functions. So putting a constant multiple, that 2 out in front, doesn't change that concept. It's still the same. Let's go ahead and find the derivative of these exponential functions. Let's start using the chain rule here. What are we going to do? What's the derivative of e to the 3x? Well, the derivative would be e to the same thing, but then we need to multiply times the derivative of that power. So it would be e to the 3x times the derivative of 3x. And I want to be clear here, the derivative of 3x does not belong in the exponent. Again, the derivative of 3x does not belong in the exponent. So what is the derivative of 3x? Well, the derivative of 3x is just simply 3. So here we would have 3e to the 3x. That would be our derivative. Make sure you put that in the answer blank, please. Let's move on. How about e to the negative 2x cubed? Well, Copy paste, that's what I always say when I teach this class. Just copy and paste. Whatever you see here, you're just going to copy it and paste it. So the derivative of e to the negative 2x is e to the negative 2x cubed is e to the negative 2x cubed. Again, we just have to remember and cannot forget, we have to find the derivative of that exponent. So what's the derivative of negative 2x cubed? Well, drop the power and multiply. That would be negative 6x squared. So what's the derivative? We would have negative 6x squared times e to the negative 2x cubed. One of the few times I'm okay with you having an answer that has a negative exponent is when we have exponential functions, that e to the power. If you notice, it's a negative 2x cubed. If this were in the previous sections, I would have forced you to throw that e into the denominator and make that power positive. But if it's an exponential function, I do not care that that power is negative, so this would be perfectly fine as your final answer. Let's look at C now. It's the derivative of 4e to the x squared. Again, exponential functions, I like to say copy and paste. The 4 stays there because it is a constant multiple. We copy and paste the exponential part, which is e to the x squared, but then we just need to remember to multiply times the derivative of that exponent. Well, the derivative of x squared is 2x. So now I just simplify. I have 4 times 2x. That would be 8x. Then we have e to the x squared. That would be our derivative. 8x e to the x squared. We keep on moving on. We have e to the negative 2x, e to the negative 2x. I want to find the derivative of that. Again, I'm going to use what is the chain rule. Okay, the chain rule gives us the general power rule, or the chain rule for exponential functions. It just says copy and paste. If we copy and paste, that's e to the negative 2x. But then we have to remember to multiply it times the derivative of negative 2x. Well, the derivative of negative 2x is simply negative 2. So that gives us our final answer of negative 2e to the negative 2x. Again, negative exponent here, perfectly fine. I do not require that you throw it into the denominator. There's no need to do that when you're dealing with our exponential functions.